You can put heat to one side of it, and eventually the backside of the tile will get hot. But for any type of re-entry vehicle, you know exactly what re-entry consists of. So you know approximately what the heat loads are going to be, so then it's just a question of designing the tile to be of the correct thickness. And I can actually take this tile and heat it up with a blowtorch, and you can see quite rapidly the surface will get up to about a little over 2,000 degrees with just this propane torch.
Okay.
But the actual heat is soaking through the tile very, very slowly. I could stand here for probably around about 20 minutes.
Yes.
Before the back of the tile becomes uncomfortably hot and I'd have to put it down.
Really? It's not hot now? On the other side?
No, it's not hot at all. I've got my finger right on the back side of it and I can't feel anything. It's probably going to take about 7 or 8 minutes before it starts to warm up. So yes, you can put your finger on the back of it.
Yeah,
it's just nothing.
Nothing.
And basically that's how most of these ceramic insulating strategies work. Just very, very lightweight. They delay that heat pulse.
Yes.
And can be used for any re-entry vehicle, be it an Earth re-entry vehicle or a one entering Mars or any other planet.
So when you think of space flight, one thing you might not immediately think of is parachutes. But let me tell you, chutes really are important. I mean, they return the solid rocket boosters back to Earth. They help slow down the space shuttle on landing. And they will be used again when we phase out the space shuttle and begin flying our next generation space vehicles. Johnny jetted over to the parachute facility to find out more.
Okay, so we are here at the parachute refurbishment facility with my buddy Terry. Terry Magoon, how's it going, bro?
Good, Johnny.
Good to see you.
Glad you could stop by.
Thank you. Tell me, what are we doing here?
Okay, what we're doing here is this place manufactures, refurbishes, repairs, and packs the parachutes for the solid rocket booster first stage vehicle for the shuttle program.
Why isn't the chute solid? Why is it
Okay,
like this?
when you see the parachutes fly, they appear solid.
Yes.
Ribbon parachute like this withstands the heavy loads and the high dynamic loads much better than a solid parachute would. If you try to put a solid parachute out with this much drag at the speeds that we're going out, you'd probably tear the parachute up. The boosters themselves, the white structures that are on the side of the shuttle system, they come back and are reused time and time again. They're certified for up to 30 flights. So we're still using the boosters every time again, so we don't build a new booster every time. We integrate the pieces into a new booster every time.
So what are these parachutes made of?
The major component, in fact, almost the only component of the SRB parachutes is nylon. The ribbons are fairly strong, but not that strong. These are good for about 1,000-pound tensile strength if you were to tear it in this direction.
Okay.
A little bit more strength here because the load on the parachute is carried by this part, and this just creates drag and holds the structure together.
How big of a space can this this incredibly long parachute pack into?
This is a big parachute.
Yeah.
And this parachute's 136 foot across at the bottom when it's fully inflated.
Right.
And we pack it into a bag, and the whole packed parachute weighs about 2,000 pounds, 2,200 and change.
Wow. Now check it out, we got a couple guys working on one right now.
Sure.
Yeah.
Well, we got Tom Gilliam and James Morrell
What's up, guys?
that are working on the parachute, getting it put in the deployment bag here.
Sure.
And as you see, what we've got, the deployment bag is inverted, and they're stuffing the parachute in vent first into the bag.
Okay.
They fold the parachute very carefully, and then lay it into the parachute deployment bag very carefully, and they tie it in all over the place with all of this 350-pound cotton webbing.
Sure.
When the parachute comes out, it pops out like you or I would pop a thread, and that makes sure that this parachute streams out and inflates correctly every time.
But let me ask you something. When these parachutes are deployed and they fall into the ocean, I mean, what do you do with them?
Okay, they fall into the ocean, and there's marine operations that goes out, and there's 2 ships that go out. One recovers the parachutes off of each booster.
Okay.
The divers go and they get them, and they put them on big reels on the back of the parachute, bring them back to us. We bring them back here and we rinse them. We don't really wash them because there's no detergent or agitation, but we rinse them out so that you get all the minerals out of it. It's seawater, it's got minerals in it. If you let that dry, it creates a crystalline structure, gets a sharp edge, and it'll mess up your parachute. It'll decrease the strength of the fibers.
Sure. So Terry, obviously there are like a million things that have to go right. You know, but this is like one thing that most people don't even think about.
Right, this is just one parachute of the parachute system.
Yeah.
This is just one process of the recovery system. The recovery system is just one process on the solid rocket booster. The solid rocket booster is just part of the shuttle system. And of course, once the shuttle system gets up, they have the orbiter that goes up, does the mission, and comes back home to do it all over again.
Amazing.
It's a very complex process. I'm really glad to be part of it.
Well, you know, Terry, thank you so much for your time.
You're
See
welcome.
you around, all right?
Yes.
All right, so we've scratched the surface a little to show a few of the things that are happening at the Kennedy Space Center. But you know, when our next generation space vehicles start flying in a few years, we'll start a whole new chapter in the long history of the Kennedy Space Center. So in the upcoming years, NASA personnel will continue working hard to reach our new national goal of getting us back to the moon and onto Mars. And guess what? All of us, we're gonna have a front row seat for it. That's it for this episode. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
And one of the main goals is to get us ready to go to space. That's not right.
Johnny is at the Thermal Protection Facility Systems.
This is where all the most important... I'm talking about just getting it ready to fly. You know? Thousands of people must perform. And if you flip it over, it's... Look at this. Or you do this. Not to mention hundreds of others. But let me tell you something. I was gonna say it ain't easy. Sorry.
For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360. I don't even know my name. That's it for this episode. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.